Right. Tonight we want to talk about Phase 3 trial of Solazumab for mild to moderate Alzheimer's disease. First, we gotta know what is Alzheimer's disease. Alzheimer's disease is a type of dementia that causes problems with memory, thinking, and behavior. Symptoms usually develop slowly and get worse over time, becoming severe enough to interfere with daily tasks. Here's a video about what is Alzheimer.
Every 4 seconds, someone is diagnosed with Alzheimer's disease. It's the most common cause of dementia, affecting over 40 million people worldwide. And yet, finding a cure is something that still eludes researchers today. Dr. Alois Alzheimer, a German psychiatrist, first described the symptoms in 1901, when he noticed that a particular hospital patient had some peculiar problems, including difficulty sleeping, disturbed memory, drastic mood changes, and increasing confusion. When the patient passed away, Alzheimer was able to do an autopsy and test his idea that perhaps her symptoms were caused by irregularities in the brain's structure. What he found beneath the microscope were visible differences in brain tissue in the form of misfolded proteins called plaques and neurofibrillary tangles. Those plaques and tangles work together to break down the brain's structure. Plaques arise when another protein in the fatty membrane surrounding nerve cells gets sliced up by a particular enzyme, resulting in beta-amyloid proteins, which are sticky and have a tendency to clump together. That clumping is what forms the things we know as plaques. These clumps block signaling and therefore communication between cells, and also seem to trigger immune reactions that cause the destruction of disabled nerve cells. In Alzheimer's disease, neurofibrillary tangles are built from a protein known as tau. The brain's nerve cells contain a network of tubes that acts like a highway for food molecules, among other things. Usually, the tau protein ensures that these tubes are straight, allowing molecules to pass through freely. But in Alzheimer's disease, the protein collapses into twisted strands or tangles, making the tubes disintegrate, obstructing nutrients from reaching the nerve cell and leading to cell death. The destructive pairing of plaques and tangles starts in a region called the hippocampus, which is responsible for forming memories. That's why short-term memory loss is usually the first symptom of Alzheimer's. The proteins then progressively invade other parts of the brain, creating unique changes that signal various stages of the disease. At the front of the brain, the proteins destroy the ability to process logical thoughts. Next, they shift to the region that controls emotions, resulting in erratic mood changes. At the top of the brain, they cause paranoia and hallucinations. And once they reach the brain's rear, the plaques and tangles work together to erase the mind's deepest memories. Eventually, the control centers governing heart rate and breathing are overpowered as well, resulting in death. The immensely destructive nature of this disease has inspired many researchers to look for a cure, but currently, they're focused on slowing its progression. One temporary treatment helps reduce the breakdown of acetylcholine, an important chemical messenger in the brain, which is decreased in Alzheimer's patients due to the death of the nerve cells that make it. Another possible solution is a vaccine that trains the body's immune system to attack beta-amyloid plaques before they can form clumps. But we still need to find an actual cure. Alzheimer's disease was discovered more than a century ago, and yet still it is not well understood. Perhaps one day we'll grasp the exact mechanisms at work behind this threat, and a solution will be unearthed.
Alzheimer's disease. The majority of people with Alzheimer are 16 years old or older. But Alzheimer is not just a disease of old age. Up to 5% of people with the disease have early onset Alzheimer's, which often appears when someone is in their 40s or 50s. Now, Alzheimer worsens over time. Alzheimer is a progressive disease, where dementia symptoms gradually worsen over a number of years. In its early stage, memory loss is mild, but with a late stage Alzheimer's, the individuals lose the ability to carry on a conversation and respond to their environment.
I'm Bill Hagine, and I have Alzheimer's. What is it like? When you're first diagnosed, it's like getting a kick in the teeth, to be very honest. But once I guess because when you're first diagnosed, everybody has this concept of Alzheimer's that it's a continuous downhill battle, and that's things are going to be over relatively quickly. Once that initial shock of the actual diagnosis was over with, I tend to ignore it, in all honesty. Yeah, we all know what the end result is going to be, but we tend to work more and more on a day-to-day basis, and one of the advantages of having a farm is I always have a reason to get up in the morning. I wish that they would see the person as opposed to the disease. It's the same person that they knew the day before, except they now have a name to whatever the problem has been. And I would like to see them continue to treat the individual as an individual, as I say, rather than pull away from them or try to treat them differently at that point. I think the biggest thing I would like to tell people about Alzheimer's disease is if you think that there is a problem with someone or yourself, go and get tested. Based on the experience I've had here in Thunder Bay, don't hesitate to contact the Alzheimer's Society. They have the expertise and the people to sit down, discuss problems with you, and the help and support is there if you need it.
Alzheimer has no current cure. Both occurring Alzheimer treatments cannot stop Alzheimer from progressing. They can temporarily slow the worsening of dementia, symptom of improved quality of life for those with Alzheimer and their caregivers.
What is Alzheimer's disease? Alzheimer's is a slow, fatal disease of the brain affecting 1 in 10 people over the age of 65. No one is immune. The disease comes on gradually as 2 abnormal protein fragments called plaques and tangles accumulate in the brain and kill brain cells. They start here in the hippocampus, the part of the brain where memories are first formed. Over many years' time, the plaques and tangles slowly destroy the hippocampus, and it becomes harder and harder to form new memories. Simple recollections from a few hours or days ago that the rest of us might take for granted are just not there. After that, more plaques and tangles spread into different regions of the brain, killing cells and compromising function wherever they go. This spreading around is what causes the different stages of Alzheimer's. From the hippocampus, the disease spreads here to a region of the brain where language is processed. When that happens, it gets tougher and tougher to find the right word. Next, the disease creeps toward the front of the brain, where logical thought takes place. Very gradually, a person begins to lose the ability to solve problems, grasp concepts, and make plans. Next, the plaques and tangles invade the part of the brain where emotions are regulated. When this happens, the patient gradually loses control over moods and feelings. After that, the disease moves to where the brain makes sense of things it sees, hears, and smells. In this stage, Alzheimer's wreaks havoc on a person's senses and can spark hallucinations. Eventually, the plaques and tangles erase a person's oldest and most precious memories, which are stored here in the back of the brain. Near the end, the disease compromises a person's balance and coordination, and in the very last stage, it destroys the part of the brain that regulates breathing and the heart. The progression from mild forgetting to death is slow and steady, and takes place over an average of 8 to 10 years. It is relentless and, for now, incurable. Helping your family, friends, and neighbors to better understand Alzheimer's will reduce stigma, improve care, and even help the fight for a cure. Thank Thanks for helping to do your part. Learn more at www.aboutalz.org.
Background. Alzheimer's disease is characterized by amyloid beta plaques, neurofibrillary tangles, gliosis, and neuronal loss. Solazumab, a humanized monoclonal antibody, preferentially binds soluble forms of amyloid and in preclinical studies promoting its clearance from the brain. Methods. 2 phases. 3 double-blind trials, Expedition 1 and Expedition 2, were randomly assigned in 1,012 and 1,014 patients, respectively, with mild to moderate Alzheimer's disease to receive placebo or Solazumab, administered intravenously at a dose of 400 milligrams every 4 weeks for 18 months.
A state of confusion in which the patient finds it hard to remember, learn, and communicate. It is also characterized by the formation of senile plaque involving the accumulation of beta amyloid and abnormal neurofibrillary tangles. Beta amyloid is derived from a larger molecule called amyloid precursor protein, or APP. APP is normally present on the cell surfaces, and the cleavage of APP results in the formation of beta amyloid. Neurofibrillary tangles consist of insoluble twisted fibers that are found inside the brain cells. The tau protein is abnormal, and the microtubule structures collapse. Recent drugs like inhibitors of cerebral acetylcholine esterase have been shown to be of some benefit to Alzheimer's patients.
The human brain is a remarkable organ. Complex chemical and electrical processes take place within our brains that let us speak, move, see, remember, feel emotions, and make decisions. Inside a normal, healthy brain, billions of cells, called neurons, constantly communicate with one another. They receive messages from each other as electrical charges travel down the axon to the end of the neuron. The electrical charges release chemical messengers called neurotransmitters. The transmitters move across microscopic gaps or synapses between neurons. They bind to receptor sites on the dendrites of the next neuron. This cellular circuitry enables communication within the brain. Healthy neurotransmission is important for the brain to function well. Alzheimer's disease disrupts this intricate interplay. By compromising the ability of neurons to communicate with one another, the disease over time destroys memory and thinking skills. Scientific research has revealed some of the brain changes that take place in Alzheimer's disease. Abnormal structures called beta amyloid plaques and neurofibrillary tangles are classic biological hallmarks of the disease. Plaques form when specific proteins in the neuron's cell membrane are processed differently. Normally, an enzyme called alpha secretase snips amyloid precursor protein, or APP, releasing a fragment. A second enzyme, gamma secretase, also snips APP in another place. These released fragments are thought to benefit neurons. In Alzheimer's disease, the first cut is made most often by another enzyme, beta secretase. That, combined with the cut made by gamma secretase, results in the release of short fragments of APP called beta amyloid. When these fragments clump together, they become toxic and interfere with the function of neurons. As more fragments are added, these oligomers increase in size and become insoluble, eventually forming beta-amyloid plaques. Neurofibrillary tangles are made when a protein called tau is modified. In normal brain cells, tau stabilizes structures critical to the cell's internal transport system. Nutrients and other cellular cargo are carried up and down the structures called microtubules to all parts of the neuron. In Alzheimer's disease, abnormal tau separates from the microtubules, causing them to fall apart. Strands of this tau combine to form tangles inside the neuron, disabling the transport system and destroying the cell. Neurons in certain brain regions disconnect from each other and eventually die, causing memory loss. As these processes continue, the brain shrinks and loses function. We now know a great deal about changes that take place in the brain with Alzheimer's disease, but there is still much to learn. What other changes are taking place in the aging brain and its cells? And what influence do other diseases, genetics, and lifestyle factors have on the risk of developing Alzheimer's disease as the brain and body age? Scientific research is helping to unravel the mystery of Alzheimer's and related brain disorders. As we learn more, researchers move ever closer to discovering ways to treat and ultimately prevent this devastating fatal disease.
In conclusion, Solazumab, a humanized monoclonal antibody that binds amyloid, failed to improve cognition or functional ability. Thank you.